Voyager 2's rendezvous with the unknown, a new look at an old mystery. This is the story of a silent emissary, sent from Earth to explore the farthest reaches of our solar system, and the enigmatic world it encountered. Launched in 1977, Voyager 2 was designed as a marvel of engineering, equipped with instruments to measure magnetic fields, plasma waves, and capture images never before seen by human eyes. Picture the blackness of space, silent and endless, until a lone spacecraft appears, gliding through the cosmic ocean, carrying the hopes and questions of humanity. For nearly a decade, Voyager 2 journeyed through the cold, radiation-filled expanse, its radioisotope thermoelectric generators powering its instruments as it sailed ever farther from the sun. This is Voyager 2, humanity's messenger, approaching Uranus after a decade-long journey across nearly 3 billion kilometers, braving intense radiation belts and the unknown hazards of the outer solar system. Its arrival marked the first time a spacecraft had ever visited this distant, icy world. Uranus emerges, a pale blue-green orb glowing mysteriously in the void, its color a result of methane in its upper atmosphere, absorbing red light and reflecting blue and green. Beneath its tranquil appearance, scientists suspected a world of dynamic weather and hidden complexity. In 1986, Voyager 2 became our first and only visitor to this distant ice giant, capturing the imagination of scientists and the public alike. The spacecraft's flyby provided the only close-up images and direct measurements of Uranus and its system, a treasure trove of data that would fuel decades of research. For a few precious hours, it captured images and data that would reshape our understanding of Uranus, revealing a world both familiar and utterly alien. Voyager 2 discovered 11 new moons, measured the planet's frigid atmosphere at -224 degrees Celsius, and mapped its faint dark rings for the first time. The planet seemed calm and featureless, tipped dramatically on its side, its axis tilted at 98 degrees, likely the result of a colossal ancient collision. Voyager 2 revealed faint rings and a bizarre, lopsided magnetic field, offset from the planet's center and tilted at a sharp angle, a puzzle that challenged existing theories of planetary magnetism. Scientists believed its magnetosphere was weak, leaving its moons exposed and lifeless, their surfaces scarred by cosmic radiation. The moons, Miranda, Ariel, Umbriel, Titania and Oberon, showed signs of ancient geological activity, but appeared frozen and battered by the harsh environment. For 40 years, this was the accepted truth, until new research challenged everything we thought we knew about this distant world. Scientists pored over Voyager's data, publishing studies and building models that shaped our understanding of Uranus for generations. Modern models revealed Voyager 2 arrived during an intense solar storm, a rare event that changed the very environment it was measuring. The solar wind, a stream of charged particles from the sun, was unusually strong, distorting the planet's magnetic field and altering the readings Voyager 2 sent back to Earth. The solar wind compressed Uranus's magnetosphere, making it appear far weaker than it truly is under normal conditions. This compression may have masked the true strength and structure of Uranus's magnetic field, leading to decades of misconceptions. We weren't seeing Uranus on a typical day, but during a rare cosmic event, an extraordinary moment in the planet's long, quiet history. The data Voyager 2 collected was a snapshot, shaped by the unpredictable forces of space weather. Our entire perception of the planet was shaped by a single, extraordinary encounter, frozen in time by Voyager's instruments. Every image, every measurement, became a piece of a puzzle that scientists are still working to solve. Now, with new insights and technology, the story of Uranus is being rewritten, reminding us that even the quietest corners of our solar system can surprise us. As we revisit Voyager's legacy with fresh eyes, we are reminded that the universe is full of mysteries, waiting for the next silent emissary to reveal their secrets. Voyager 2's Odyssey stands as one of humanity's most ambitious and enduring scientific achievements, a testament to our curiosity and ingenuity. Launched in 1977, Voyager 2 took advantage of a once-in-176 years planetary alignment, using gravity assists to slingshot from Jupiter to Saturn, Uranus, and Neptune. Each flyby transformed our understanding of the solar system. It revealed Jupiter's swirling great red spot and volcanic activity on its moon Io, Saturn's intricate ring structure and mysterious hexagonal storm, and Uranus's extreme axial tilt, which causes its seasons to last over 20 years each. During its historic Uranus encounter in 1986, Voyager 2 discovered 10 new moons, 2 previously unknown faint rings, and measured the planet's frigid atmosphere, finding it to be the coldest in the solar system at -224 degrees Celsius. The spacecraft's instruments captured hauntingly pale images of Uranus and its enigmatic moons, such as Miranda, with its bizarre patchwork surface. The data and images Voyager 2 sent back traveled across nearly 3 billion kilometers, taking over 2.5 hours to reach Earth. These transmissions provided humanity's only close-up look at Uranus, unlocking secrets hidden for billions of years. Today, Voyager 2 continues its journey beyond the edge of our solar system, venturing through the uncharted territory of interstellar space, now more than 13 billion miles from Earth, still sending faint signals home. On board, it carries the Golden Record, a time capsule of sounds, music, and greetings from Earth, intended for any intelligent life that might one day find it, a message of hope and curiosity cast into the cosmic ocean. Voyager 2's legacy is not only in the vast trove of scientific data it returned, but in the generations of scientists, engineers, and dreamers it has inspired to push the boundaries of exploration and knowledge. Its journey reminds us that the universe is still full of mysteries, waiting for us to discover, and that our quest to understand the cosmos is far from over. For decades, Voyager 2's historic flyby in January 1986 was our only window into Uranus, offering a fleeting, tantalizing glimpse of this distant, enigmatic world. The spacecraft raced past at over 64,000 kilometers per hour, gathering precious data in just a few hours, a brief encounter that would shape our understanding for generations. Its instruments revealed a magnetosphere unlike any other in the solar system, strangely tilted at nearly 60 degrees from the planet's axis and offset from the center by a third of Uranus's radius. The field appeared weak and lopsided, leading scientists to believe that Uranus's moons were likely sterile, unprotected from the relentless bombardment of cosmic and solar radiation. But decades later, with the advent of advanced computer modeling and a new generation of planetary scientists, researchers began to re-examine Voyager's data. Sophisticated simulations, combined with a deeper understanding of solar-wind interactions, began to unravel a more complex story. It turned out that Voyager 2 had unknowingly flown through a rare, powerful solar wind event, a kind of cosmic hurricane with charged particles streaming from the sun at extraordinary speeds. This tempest compressed and distorted Uranus's magnetosphere, masking its true strength and structure. The solar wind's immense pressure squeezed Uranus's magnetic field, making it appear much weaker and more vulnerable than it actually is under typical calmer conditions. The planet's magnetic shield was temporarily overwhelmed, not fundamentally broken. In reality, Uranus's magnetosphere is far more dynamic, robust, and ever-changing than we first imagined. Its unique tilt and offset create a constantly shifting environment, with the magnetic field lines opening and closing as the planet rotates, sometimes exposing the moons, sometimes shielding them. This leaky shield effect means that Uranus's moons experience a complex interplay of exposure and protection. At times, the magnetosphere allows solar wind to penetrate, but often it deflects and absorbs the worst of space's dangers, creating pockets of relative safety. This revelation forces us to reconsider the environment around Uranus and its moons. The possibility arises that beneath their icy surfaces these moons could harbor more complex chemistry, perhaps even prebiotic molecules, shielded at times from radiation by the planet's dynamic magnetic field. The planet's shield wasn't shattered, it was simply caught off guard, momentarily overwhelmed by the solar wind's deceptive power. As the storm passed, the magnetosphere rebounded, regaining its strength and complexity. Our old assumptions were based on a single, misleading snapshot in time, a moment when the planet was under siege, not a true reflection of its normal state. The full story was hidden in the data, waiting for new eyes and new tools to reveal it. Now, we see Uranus as a world with a far more complex, dynamic, and protective environment than we ever realized. A planet whose secrets are only beginning to be unveiled, and whose moons may hold surprises yet to be discovered. The discovery of a stronger, more complex magnetosphere around Uranus has revolutionized our understanding of its 5 largest moons: Miranda, Ariel, Umbriel, Titania, and Oberon. This invisible shield not only shapes the space environment around these distant worlds, but also hints at the possibility of dynamic, active processes occurring beneath their icy exteriors. Suddenly, these moons are no longer just frozen relics. They are potential habitats, raising profound questions about the conditions necessary for life far from the sun. For decades, scientists believed these moons were little more than inert frozen wastelands. But new data and advanced modeling suggest that beneath their thick, icy crusts, vast oceans of liquid water may be hidden, kept warm by internal heat and insulated from the frigid vacuum of space. Much like Jupiter's Europa and Saturn's Enceladus, moons already known to harbor subsurface oceans, Uranus's moons could possess similar environments. Tidal forces, generated by gravitational interactions with Uranus and neighboring moons, flex and heat their interiors. Combined with the slow decay of radioactive elements in their rocky cores, this energy could maintain liquid water for billions of years, creating stable, long-lived oceans beneath the ice. The planet's powerful magnetosphere acts as a protective barrier, deflecting harmful charged particles and cosmic radiation. This shielding effect is crucial. It preserves the delicate chemistry of these hidden oceans, preventing radiation from breaking down complex molecules that could be essential for life. Among Uranus's moons, Titania and Oberon stand out. Their larger sizes and higher rock-to-ice ratios make them especially promising candidates for subsurface oceans. Models suggest that their interiors could contain enough heat and pressure to sustain liquid water and perhaps even hydrothermal activity at the ocean floor. On Earth, life thrives in the most extreme environments, at hydrothermal vents deep beneath the ocean, where sunlight never reaches and energy comes from chemical reactions. If similar vents exist in the oceans of Titania or Oberon, they could provide the energy and nutrients needed for alien life to emerge, independent of sunlight. Detecting liquid water beneath the ice is the first step in the search for extraterrestrial life. Scientists use techniques like ice-penetrating radar and magnetic field measurements to look for signs of subsurface oceans, such as changes in the moon's magnetic signatures or subtle shifts in their rotation. This new scientific perspective transforms Uranus from a remote, enigmatic planet into a prime target for astrobiology. The possibility of multiple ocean worlds orbiting a single planet is unprecedented, making Uranus a natural laboratory for studying the origins and diversity of life in the universe. Evidence of recent geological activity, such as cryovolcanism, shifting ice, or even plumes of water vapor, suggests that these moons are not static. Instead, they may be geologically alive, with processes that continually reshape their surfaces and interiors. Future missions could send robotic probes to land on Titania or Oberon, drilling through kilometers of ice to reach the oceans below. Sampling these alien seas could reveal not only the chemistry of another world, but also the tantalizing possibility of life beyond Earth. The secrets locked beneath Uranus's icy moons may hold the answers to one of humanity's oldest questions. Are we alone? As we look to the future, these distant worlds invite us to explore, to dream, and to imagine what wonders might lie hidden beneath their frozen surfaces. Voyager 2's historic journey past Uranus in 1986 didn't just expand our scientific horizons, it also sparked a wave of myths and speculation, including persistent rumors about mysterious artificial signals detected near the planet. In reality, every byte of Voyager's data has been meticulously analyzed and made public by NASA. No evidence of artificial or unexplained signals has ever been found in the vast troves of information sent back to Earth. What Voyager 2 did detect were natural radio emissions, complex fluctuating signals generated by Uranus's powerful and unusual magnetosphere. These emissions, captured as eerie sounds, are the result of charged particles spiraling along magnetic field lines, not evidence of extraterrestrial technology. Despite clear scientific explanations, these strange sounds were often misinterpreted, fueling conspiracy theories and sensational headlines that blurred the line between fact and fiction. Yet the true discoveries from Voyager 2 are even more astonishing. Uranus's extreme axial tilt, which causes it to roll around the Sun on its side, its lopsided, rapidly shifting magnetic field, and the presence of dark, enigmatic moons, all of which challenge our understanding of planetary science. The only signals Voyager 2 ever received from Uranus were the planet's own natural whispers, echoes of a world still holding many secrets, waiting for future explorers to uncover. The story of Uranus shows how science evolves, claims are tested, facts replace myths. Early observations painted Uranus as a featureless, distant world, but Voyager 2 changed that perception. Voyager 2's flyby was just a glimpse. New research has rewritten the story. The spacecraft revealed a dynamic planet with a complex atmosphere and a unique magnetic field. Now, Uranus's magnetosphere and moons are more intriguing than ever. The planet's magnetic field is tilted and offset from its rotational axis, creating a lopsided magnetosphere. A dedicated orbiter could map its magnetic field, study its weather, and search for hidden oceans. Such missions could provide insights into the planet's internal structure and atmospheric dynamics. Missions to Uranus could launch in the next decade, finally answering questions that have lingered for half a century. These missions would build on Voyager 2's legacy, using advanced technology to explore the planet in greater detail. Exploring these distant worlds is about more than finding life. It's about understanding our place in the universe. Each discovery brings us closer to comprehending the vastness and complexity of our solar system. Voyager 2's legacy is the inspiration to keep reaching outward. Its journey has paved the way for future explorations, reminding us of the endless possibilities that lie beyond. There are still mysteries to solve, and new worlds to discover. Each mission uncovers more questions, driving the quest for knowledge ever forward. The silent blue giant waits, its secrets ready for the next emissary. With each passing year, our understanding deepens, and the promise of new discoveries grows. The journey continues, written in Starlight. As we look to the stars, we are reminded of the boundless potential that lies ahead. As we stand on the threshold of new exploration, Uranus is just the beginning. The lessons learned from Voyager 2 and future missions will not only unlock the secrets of this distant giant, but also set the stage for journeys even farther from home. Scientists dream of venturing to Neptune, the Kuiper Belt, and beyond, each world holding clues to the origins of our solar system. The technology we develop to survive the cold, the darkness, and the vast distances will shape the future of space exploration itself. Perhaps one day, spacecraft will soar past Uranus, carrying robotic explorers or even human ambassadors to the edge of interstellar space. Each mission is a stepping stone, a testament to human curiosity and our relentless desire to know what lies beyond. In the silent expanse, every discovery is a whisper from the cosmos, urging us onward. The promise of Uranus is not just about understanding a single planet, it is about embracing the unknown, daring to dream, and reaching for the infinite. As we chart our course to the stars, the next frontier awaits, ready to reveal its wonders to those bold enough to seek them.